Solving exponential equations practice. We're going to solve the following exponential equations algebraically, finding the exact value and then the approximate value to the nearest 10,000. Confirm your answer by graphing and finding the intersection point. I'm not going to spend my time on confirming the answer and graphing and finding the intersection point, but I will do the rest of this. And the first thing that we talked about when we were working with these types of problems is we said that we need to really isolate the exponential as much as possible. So it's 6 times e to the x, the opposite operation. Then it's going to be the divide, both sides by 6. So now we have e to the x equals 8 when we divide 48 by 6. Well, at this point here, what we're asking is it's e to what power equals 8. Because e is an irrational number, we don't know what that answer is. But what we can use to help here is we can use a natural logarithm. And one of the reasons why I chose to use the natural log is because the base is e in the natural logarithm. So this is e to the x equals natural log of 8. And as we use our properties, we remember that we can take this value of x and we can write it out in front of our logarithm. So now we have x, natural log of e, equals natural log of 8. Well, another good thing, and you can confirm this in your calculator, but the natural log of e is 1. So over here, this is going to be x times 1 equals natural log of 8. And there's a lot of you who aren't even going to write that fact, because x times 1 is x. And that is our exact answer. The approximate answer. Well, that's when we take out our calculators. We're going to type that in. So, natural log of 8 gives us that value rounded to the nearest 10,000. Well, that's going to be x equals 2.0794. Remember, we're looking at that second 4, and because it's less than 5, this first 4 remains the same. And on second thought here, we can take a look at the intersection point. So if we pull out our calculator again, just as a quick refresh, again, I don't want to spend all my time on it, and it's the issue of getting the right window. But what we can type in one of our screens is 6 e to the x for y1. For y2, we're going to type in the other side of the equation, which is 48. And then the thing is, when we look at the picture here, that's all we're going to see. Because we have to change that window, and remember the second equation is y equals 48, so we need to change our window. And I left the x alone, but what I did is I changed here. I changed the y minimum to 0, and I changed my maximum to 100, and I changed my y scale to 10. And now we can see the picture. We can see the whole picture. And what we want to know is, what is the value of this point right here? Whoops, I'm trying to get that right there. Where those two intersect. The way that we use our calculator to help us find that is we go to second and then to the trace button, which gets us up to calculate. Number 5 is the intersect. And we're going to go on the first curve. I'll stop it there. Close to where it intersects. Press enter. When it jumps over here to my second curve, so to speak, I leave it alone. I leave it right there and then press enter. And then the third time I press, it's going to give us our intersection. And look at the value there that's on that calculator screen. To cover up my other one here, the value here is 2.0794. 48. Now look back in the problem. Look what we got. the value for x, and then the other side of their equation gave us the y value. Again, I'm not going to spend all of my time calculating those out, but at least that gives you some idea of what you're working with as you work these problems out. And once again, isolate. If you don't isolate, things are going to go wrong quickly. 4 to the x minus 5 equals 12. First thing we're going to do, add 5. Both sides. And we get 4 to the x equals 17. Well, in order to solve that, we need to use a logarithm. And I'm going to put log in for both sides. Now, if you have Mrs. Krause as a teacher, she likes to use the natural log for every single time, and there's nothing wrong with it. The process is still going to be the same. It's just that you're going to be using the ln button on your calculator instead of the log button on your calculator. But we put log in. We're going to use our properties of exponents once again to take this x and write it out front of our logarithm. We have x log 4 equals log 17. And our goal is to solve for x, and this is x times log of 4. So the inverse operation is going to be to divide by log 4. And we end up with x equals log 17 divided by log 4, which is our exact answer. Log 17 divided by log 4. Our approximate value, then, is going to be what we get when we type that in. You do not have to use your fraction button to get this. We can simply type in log of 17, close the parentheses, divided by log of 4, close the parentheses. And when we hit enter, we get our values of 2.0437. Once again, in terms of rounding, look at the 3 to determine what to do with the 7. Since 3 is less than 5, we're going to keep the 7 as is. And remember, that value of 2.0437 is going to be the x value of our intersection point. And if we look back at our equation, the other side of that is going to be 12. Type it in. You don't have to make your y scale so much different this time. You could just make y going up to 15 and you'll be able to see the picture. If you make 0, y min 0, y max 15, and leave it as a scale of 1, you'll be able to see that on your calculator. Number 3, isolate. Divide both sides by 10. And 16 divided by 10, 1.6. Equals 1 plus e to the x. Subtract 1 from both sides. And we get 0.6 equals e to the x. And now we're at a point where we can use the logarithm, and once again going to use the natural logarithm. Using the natural logarithm because there's an e in this problem. Got interrupted for a minute, but we're going to put in natural log in for both sides. It's natural log of 0.6 equals e to the x. And here comes our power property yet again. This x is going to go out in front. So we have x natural log of b equals natural log of 0.6. And a reminder, you can type it in your calculator, but you don't need to. The natural log of e is simply 1. This is x times 1 is the natural log of 0.6. Well, x times 1 is just x, so natural log of 0.6, I'm going to write it just a little bit better. Natural log of 0.6, that's our exact answer. Then we can type that value into the calculator, and we type that value into the calculator. Natural log 0.6 gives us that value here for our approximate, which is negative 0.5108, looking at the 2, and 2 is less than 5, so the 8 is going to remain the same. And in terms of our intersection point, it's going to be negative 0.5108, and then our y value, as we look back in the problem, is going to be 16. Again, on your calculator, if you are going to type this in there, what I would do for your y min is make it 0, your y max make it 20, and leave your scale as 1, or you might make it 2. Either way I think should work, and you'll be able to find that point if you use the second calc intersection. Problem number 4 is already isolated for us, so we can go directly to the part where we put in a natural log. Put a natural log in on the left side, put a natural log on the right side. Next, we take this 3x, we're going to write it out here in front. We have 3x. Natural log of equals natural log of 48. Just like the last problem. Natural log of e is 1. And a lot of you aren't going to write that, but hopefully you will at least write the step before that. So you probably go directly to 3x equals the natural log of 48. And then it's 3 times x. Opposite operation is to divide by 3. And that's going to give us our exact answer, which is natural log of 48 by 3. I'm going to make my box bigger here so I can fit things in. That's our exact answer. Natural log of 48 divided by 3. Type in our value in our calculator. Natural log of 48 divided by 3 gives us this. So we end up with 1.2904. Again, there's a 0 after the 4, so the 4 is going to remain the same. And the value that we're finding here with the exact or with the approximate is going to be our x value down here in our intersection point, the 1.2904. And hopefully at this point in time you can tell me what the y value is going to be. It's going to be 48. I would say that you might want to put the same parameters in for y if you are going to use your intersection button on your calculator, which would be y minimum of 0, y maximum of 100, and then the scale of 10, something like that, like we did on that first problem.